Welcome to another episode of HVACR Versed. As the title states, we are going to be talking about A2L refrigerants, the facts, and get rid of some of the myths and some of the misconceptions of what we're going to have to do with the new refrigerants. And the reason why I'm bringing this forward is because a lot of the manufacturers have started stating that their equipment is going to start shipping within the next 60 days, I believe, is what I've been told by American Standard, Trane, and Carrier. Their equipment will start shipping in the next 30 to 60 days, which means that before we were talking about equipment not shipping till like middle of quarter three. Well, that would mean the equipment we'd start seeing on the shelves around middle of quarter four. We're probably going to see this equipment coming into our market sometime around either the middle or end of quarter two. Now, I'm not exactly sure when they're going to come out with it, but this is all factual information. No, this is what I believe. Now, if I do have an opinion on something, I'm going to put a little bubble up here saying this is my opinion or this is my belief. Now, if it's a fact, I will just have the information spelled out clearly. So, we get into what the different types of refrigerants are. We already know what the current refrigerant we have is, which is 410A, which is an A1 refrigerant, which means it's not flammable, not toxic. Now, I didn't say it didn't displace oxygen. I said it's not toxic. Now, A2L refrigerants have been in existence for quite some time. But it was called B2L refrigerant, which is anhydrous ammonia R717, and that is a B2L refrigerant, which means it is a mildly flammable refrigerant, but also very toxic. Now, these refrigerants aren't considered toxic, but they still displace oxygen. Well, we have our A3 refrigerants, which are our R290, our R600, which is isobutane. Then you have your, trying to think what the other one is that they have out there, but anything that is easily ignitable is an A3 refrigerant. If it takes an extreme ignition source, it makes it an A2L refrigerant. And then you have your A1 refrigerants, which don't ignite. Now, 410A is 50% R32 and 50% R125. And everyone goes, well, how come it's got R32, which R32 is a A2L refrigerant? How come it's not a mildly flammable refrigerant? Well, that R125 is a fire suppressant, and that refrigerant, the R125, is what puts us over that GWP, which we're going to talk about what actual GWP is. So I'm not trying to get political in this. I'm just trying to spell the facts out and what's a myth and what's not actually going to happen. So R125 still is in existence. You find it in fire suppression systems for like clean rooms, stuff where they can't use water to put out a fire. They use R125. Beats halon. Halon was very detrimental because it had chlorinated gas in it. But we're not going to get into the whole chlorinated gas and the GWP thing now. So what is R454B? R454B is 69% R32. There's our higher end of the A2L spectrum. And then it's 31% 1234YF. Well, 1234YF is already in a lot of vehicles. It's been in several vehicles for the past, I think, like 12 years. What brings the R454B down to that lower GWP level is the 1234YF. The R32 by itself makes it over what the EPA is calling for GWP. So it's very hard to ignite. It has the lowest GWP. It has 466 on the GWP scale, which is global warming potential. Then we get into R32, which Daikin Goodman is going to, and depending on how deep their pockets are, it may be around for a while. I don't know. When it originally was talked about, it was said it was like 600 and some GWP, but with testing from the UL and the EPA, they found the GWP of R32 to be 771. Still hard to ignite, but it is lower to ignite than R454B. So what is the GWP? GWP is how long the refrigerant retains its heat and how long it lasts in the atmosphere. Minimum GWP is now 700. So when it was originally listed by AHRI or ASHRAE, it was 750. And the EPA came out like a couple days later and said, nope, it's 700. So this can change. This can change from the time that this video gets posted to tomorrow. I don't know, but these are things that the way it's currently at right now. So R32 has an LEL, which is your lower explosive limit of 14%. The concentration has to be 14% of the space to light, and it takes 30 millijoules to ignite. To give you an example of what a millijoule is, about 30 millijoules is what a spark plug creates. Then it'll have a higher discharge temperature, approximately about 20% slower in velocity and 20% lower charge, and it's going to have a heavier oil than the current POE right now. It'll still be POE oil. That polyester oils need to maintain in order to keep this refrigerants traveling the oil. It's going to be probably like we're currently using POE 32. It might be something like POE 38 or POE 40. R454B has a lower explosive limit of 11.8%, and its upper explosive limit is 23.6%. So that means it has to be 11.8% concentration in the room to ignite, and then it has to be anything over 23.6% concentration in the room is considered above its ignitable space. Now, there's guidelines that are going to go further down this list that are going to tell us otherwise. So to ignite it, it requires 100 plus millijoules to ignite. It has a slightly higher discharge temperature. I mean, slightly higher. Approximately 10% slower velocity, 10% less charge, and it will have a slightly lower operating pressure than 410A. Okay, well, what does that mean? Well, our equipment's probably going to get a little bit smaller. For sure. The equipment's going to have to get smaller because piping sizing is going to change. We're not going to want to have as much charge in the system, etc. So now we're going to look at what are our new regulations on it. Well, the high pressure cutouts are going to be 600 psi rather than that 650 or 625 with 410A. So it's going to be operating at a slightly lower pressure. Well, we're going to have smaller refrigerant line sizes, which means we're probably going to have smaller TXVs. So the TXVs are going to be smaller, which means you're not going to be able to take a TXV that we had on the shelf and put it in the system because it might not respond the same to these new refrigerants. They're going to want us to cut out components rather than soldering them in. Okay? There's going to be red indicator tabs for the guys that have worked on R290 and R600, which is propane and isobutane. You already are familiar. They paint the lines red so that way you know, hey, there's a flammable refrigerant in here. We need to take caution. They're going to put red indicators on every access port of the equipment. If you can put a gauge on it, there's going to be a red tab on there. Now, they're going to require those tabs to stay there as indicators for other companies. Not every technician is going to pay attention, but this is going to be a sign that says, hey, this refrigerant is slightly flammable. Take caution, be careful. We will have to document total system charge on the equipment, what the manufacturer delivered the equipment with, what we added to accommodate for line size, and what our total charge was. Then we have to put our dealer info in and all our information on the equipment. Every manufacturer is going to have this. This is a UL standard. UL is requiring this, Underwriter Laboratories. So locking caps are required now. Now, let's put that into quotation. Locking caps. What is a locking cap? Is it one that requires that fancy little special tool to open it up? Or is it a cap that just requires a tool period to open it up? Per the UL, now everybody can fight me on this. I fought home inspectors on this. Per the UL Underwriter Laboratories, the Hex Caps, the ones that have the flat spots on them, are considered locking caps. The reason why they're considered locking caps, if we're putting them back on correctly, we slightly tighten them down with the backing wrench, and it requires a wrench to take it off now. Now, caps that are behind panels can stay plastic and do not require locking caps because it is considered that you need a tool to remove that panel, and which shows that you have some mechanical competency to remove that panel, and you're taking risk at your own precaution at that point in time. That is what locking means. You are disabling it and requiring a tool to access said item. So fight me on that all you want, home inspectors. I don't care. That is per the Underwriter Laboratories. So either new refrigerant hoses will be needed, or we will have to get left-handed tank adapters for the A2L refrigerants because it won't be right-hand thread anymore. It'll be left-hand thread. I would prefer just to get a tank adapter rather than having to get all new hoses. It makes no sense. The pipe sizing is smaller. It is similar to what R22 line set size were. Now, I'm going to go over some of these line set sizes, and this is for Train and American Standard equipment, and it's looking like most of the other manufacturers are going to have to do this as well. I'm just going to get back to this. So the service valve on the 2 tons are going to have half, and this is for their single stage equipment and possibly 2-stage and inverter equipment. We're not sure yet. The 2-stage and inverter equipment has not been discussed on pipe sizing and requirements for that. And the reason why the pipe sizing has to be smaller is for oil travel and refrigerant travel and needing less refrigerant, because we don't want to have a bunch of refrigerant that's slightly flammable. So on 2 tons, it's going to be half for your suction service valve, 5/16 for your liquid. Now, this is all the way up to 5 tons. All the liquid service valves will be 5/16. 3 ton will be 5/8 suction service valve. 4 ton will be 3/4 service valve, and 5 ton 3/4 service valve. And those are the rated line sizes for those pieces of equipment. We may have to get back to doing line size calculations for this equipment. Now, there is an alternate line size for this equipment. All of it states we can use 3/8 as long as we're under 100 feet and we don't have more than 45 feet of lift. So we can use 3/8 for the liquid line, but our suction on 2 ton is 5/8, 3 ton is 3/4, and 4 and 5 ton is allowed to be 7/8 for oil travel. Now, that's subject to change, but that's where it currently sits at right now. So our pipe sizing is going to be a little bit smaller. We're going to have to get used to that. The UL guidelines for working on R454B or R32 is, now I'm going to give you 2 sets of guidelines. One is per the UL, Underwriters Laboratories, and the other one is per ASHRAE. So UL states, safely remove refrigerant following national and local guidelines. Evacuate the system. Purge circuit with inert gas. Evacuate system. That means pull a vacuum. Continue to purge when using an open flame. Open the circuit up. And that's what the UL guidelines are. These are the ASHRAE guidelines. ASHRAE guidelines state, remove refrigerant. Purge with an inert gas, nitrogen. Cut out the component. They don't want us unbrazing these materials unless we can 100% verify that we have 0 PSI and no possible of flame propagation. So purge with inert gas, cut the component out. They're strongly recommending cutting compressors out and not unsoldering them. I have seen 410A throw a little flame ball up when you're unsoldering the discharge because that oil mixed with that R32 creates a little fireball. Replace said component, perform leak check, evacuate and recharge, perform function test, and leak check your repair. So, for subcooling, we need to focus on saturated liquid for the pressure temperature chart. If we're using wireless probes such as the Field Piece, the Yellow Jackets, the JBs, we need to make sure that on our application we have it set to liquid, not discharge, because there is a difference between vapor and liquid on the PT charts. Let me just go ahead and bring that up here real quick. So if you look here, this is off of Opteon's their the Opteon refrigerant for 454B. We scroll down. Let's just say it's a 95 degree day, 115 degree liquid saturation is what we're looking for. So we scroll down to 115 degrees. Now, in this column is liquid, and in this column is vapor, right? So we have liquid and vapor. Scroll down, at 115 degrees, we're going to have 384.86 psi of liquid. Well, in the vapor side, we're going to have 373.83 psi on vapor. So that's why we need to make sure our probes are set for the appropriate setting that we're going to be using. Now, if we're going to be using a regular PT chart that's got bubble and dew point on it, if we're doing the liquid, we need to be looking at the bubble point. If we're doing the suction saturation, we'll be looking at the dew point on the PT chart. So, and if you have these field piece S-man gauges or the Testos, try to get those updated for the newer refrigerants and make sure you're paying attention and comparing, because there is a huge temperature difference. You can see that is over 10 degree temperature difference, or over a 10 psi pressure difference for that same temperature with its vapor or liquid. So versus 410A, we go down to 115 degrees right here, and we see there's like a point, like what, 8 psi difference on 410A, and that was because 410A was a 50-50 blend. Our 454B will not be a 50-50 blend. As I stated before, it's going to be, let me pull it back up here real quick. 454B is going to be 69% R32 and 31% 1234YF. That is why there is that glide in that PT chart. So we need to make sure that we're paying attention to that stuff. So with that being said, and we're paying attention to all those things, and we're making sure we're doing the correct thing. Now, R32 should not have a glide because R32 is a pure refrigerant, like R22 was. They still want us to charge both refrigerants as a liquid. Even though there is a small glide on R454B, which we're going to talk about the top-offs and stuff like that towards the end of this, so that way everybody understands. So we want to, for subcooling, we want to focus on our saturated liquid pressure temperature. If we're using wireless probes, be sure to set to liquid, not discharge, when we're checking the high side to make sure we're getting an accurate subcooling measurement. If more than half of the charge is considered lost, remove all refrigerant and put virgin in for glide reasons. Anything over half, they're saying you're going to have too much of a glide and you're going to have problems. The glide that they said on 454B is a 2 degree glide versus 410A was a 3/10 of a glide. So, and if you've had a system where you've had to do multiple top-offs, you may have to change the charge and put fresh charge in because we don't know where that charge is sitting at. So if you start having some issues and the customer saying, hey, charge has been every like 6 months, I have to get some refrigerant added, and now the system's not behaving normal at all, you probably have a glide issue going on, and it's time to pull that refrigerant out. So let's go to mitigation. What is mitigation? Mitigation is they're trying to mitigate the refrigerant from becoming flammable and igniting in a home. So this is where I'm going to get to some of those myths and beliefs. So mitigation is try to keep charge as low as possible. So they want to maintain the refrigerant as low as possible, minimizing refrigerant accumulation if a leak occurs. So the mitigation is to minimize accumulation of refrigerant if a leak does occur. They don't want it accumulating in the air handler. They don't want it accumulating into a room. And that's why they're having these mitigation boards put in, or whatever they want to call them, leak detection boards. So the system charge is not to exceed 25% of lower flammability limit. This is in regards to the size of space the equipment is cooling. So you cannot put a 2-ton split system on a 95 square foot room. You can't do it because that is too much refrigerant for that small room, and you just wouldn't want to do that. It's not best practices. And this all plays back to using best practices in the field. So the system charges not to exceed 25% of lower flammability limit. That's how much refrigerant can fill that space up. And if it's above that 25% of that limit, then we don't want to do it. So there will be 3 types of sensors specific to the refrigerant, whether it's R454B or R32. There will be specific sensors in the system. Now, Trane and American Standard has stated, and Carrier, that those sensors will be interchangeable. They just don't know what sensor they're actually going to be using. There will be a mitigation control board, leak detection control board. The sensors may need to be relocated for split systems based upon application. So they're stating that these air handlers are shipped in vertical application. That's how the sensors are already set up in the system. Well, if you're going to put the air handler into a horizontal application, you're going to have to relocate that sensor. They make the wires long enough to do it, and they have a spot for you to already do it. It goes back to RTFM. Read that fabulous manual in order to determine where that sensor needs to go. And it's looking like it's probably going to go on the drain pan, because we all know these refrigerants are heavier than air and settle to the bottom. So the mitigation control board brings the blower to full speed in cooling mode, as if it was in cooling mode, shuts the compressor off, and all accessories must be shut down. UV systems, electrostatic filters, everything must be shut down. Now, Trane has stated they will have 2 sets of dry contacts to do this, to shut this equipment down in the event of a leak. So it sees a leak, it'll open those dry contacts and shut those components down. So if it's a zoned system, all zones must open up. Now, if you have a Carrier or a Trane, I'm not going to talk about anybody else's proprietary zone system because I don't know about them. I do know that Trane and Carrier zone systems are communicating, and their systems will talk to those zones and force every zone to open up and allow every room to get equal amount of air to mitigate and send that refrigerant out and evenly disperse it so it doesn't pool up into one room. So once mitigation clears, the board is to go out of lockout and allow system to function normally. They are making these boards to be soft lockouts only during an active alarm for at least 5 minutes, and then it'll allow the system to operate again. So there's currently no requirements for an alarm signal to exist. So we don't have to have like some kind of indicator saying, hey, there's a refrigerant alarm, whatever's happening. There's nothing required by the UL so far on this. Now, Trane has stated they're going to have a set of dry contacts in their mitigation board to allow if we have to add something in the future. There will be no more partial changeouts. So back in the R22 days, when early 2008 to 2010, we were getting dry charged units and we were putting that in. And the question was asked, well, if I have a furnace it's got a coil that's only like, I don't know, 3 years old, and I'm going to replace the condenser, can I put a 454B condenser in? The answer is no. We cannot do that. 1, the coils are not going to be designed the same. 2, it is not allowed. Now, if they're going to have dry charged equipment, none of the manufacturers have stated whether they're going to do that or not. We don't know yet. They're all kind of up in the air still. If they're going to go to dry charged equipment, that'd be awesome, because we're going to have 410A equipment that's still under warranty for at least another 11 years, right? So condensers will not be allowed. So no more partial changeouts. So condensers, this is one of those myths that I keep hearing about. Oh, no more contactors, no more transformers, no more this. That is wildly inaccurate. That is not the case. So, per Underwriter Laboratories, your Outdoor units will still utilize the same contactors, the same transformers, the same open style relays. It is still going to be in existence. The reason being, sorry, forgive me. The reason being is it's outdoors. It's the cabinet's considered intrinsically separated from the rest of the equipment. So all that stuff, if there's a leak in the outdoor unit, it's just going to the outside and you have infinite air for it to go out and disappear to. So all this stuff is going to still maintain the same. You'll still be able to use the same contactors, same relays, same transformers. It does not change for the outdoor equipment. So I want to talk about what is GWP. GWP is how long the refrigerant retains heat and how long it lasts in the atmosphere. That's where they're getting us, and they're holding us by the testicles or the boobies, whatever. You know, they're gripping us, and they're making us ones that have to be the bad guys for all these consumers. These are just some of the things that are facts. Now, right here, this is an opinion. They have stated that the reason why now I'm going to tell you guys, let's take the opinion back down. The Appion G5 Twin recovery machine is A2L rated. The Field Piece MR25, or I think it's MR45, I can't remember off the top of my head, recovery machine is A2L rated. These are all A2L rated recovery machines. Now, if you have a DC driven battery powered vacuum pump, that is an A2L pump because you don't have an open spark. If you have any of the new A2L vacuum pumps, great, it's all a thing. Now, back to my opinion. So, the reason why they're saying that we need these special vacuum pumps and these special recovery machines is because in the events of operating in the indoors, there's nowhere for this vapor when you're recovering, if it does have vapor does get out, for it to go anywhere. Or you're pulling a vacuum, if there is any vapor in the system, for it to go anywhere, you're going to put it inside the house. So, my personal opinion, we don't often pull a vacuum inside the house. So I think for a while we're going to be safe on not having to buy new vacuum pumps and new recovery machines, because 99.99% of our work that we're going to be doing with vacuum pumps, recovery machines, is outside. Well, Kevin, how come they didn't require this for R290 and R600 when they put it in the refrigerators and stuff? Because the charge amount was so low and you don't recover R290 and R600. So that is the reason why. Now, that was my opinion on it. Now, the technical answer, take my opinion back down. They want you to do this right away. That's what they want. They want you to purchase all this equipment right away. They want you to use brass wrenches, spark-free. I call shenanigans on that, but that's not my call. And it's these, you guys run your own companies and do your own thing, and you have to make your own big boy decisions. So with that being said, I'm going back to my opinion. For the first little bit of time, we're going to be recovering refrigerant from either R22 or 410A systems and pulling that out. Oh, the other thing, you can't put a 454B coil condenser and coil, take my opinion back down. You can't take a 454B condenser and 454B indoor coil and put them on an older furnace. You cannot do it. It has to have the correct furnace because you have to have those mitigation controls in there to stop in case there is an event of a leak. Sorry, I had to stop there for a second. I got a technician that keeps blowing my phone up. So we have to make sure we're following UL ASHRAE guidelines, the NFPA, which is the National Fire Protection Agency. Can't get my words out today. The National Fire Protection Agency. And we're also going to have to follow the EPA guidelines and your local regulations. So you cannot do those change outs on that equipment. So back to my opinion based. Guess what? Opinion. For the first year and a half or so, I think we're going to be safe on the recovery machines and vacuum pumps because we're going to be recovering 410A equipment, R22 equipment, and to put this 454B or R32 if you're doing Daikin Goodman. Why would you need a piece of equipment to recover something that we already do? 410A, we already recover, we already have the equipment. You're not pulling a vacuum on a system with R32 or R454B in it because you should be pressure testing with nitrogen, etc. Oh, that's the other thing. So now that my opinion's out of the way, take my opinion back down. So they want us to pressure test the equipment at 600 PSI. You know, before it used to say don't test your indoor coil past 150 PSI. Well, now they're going to want us to test our equipment to 600 PSI. Not 605, not 610, not 650, 600 PSI. And they want that pressure to hold for, I believe it is 30 minutes with that dry nitrogen. So these are the things that are coming, and it's coming sooner than we thought. We were originally thinking that we weren't going to see this until sometime in 2025. Well, guess what? We're probably going to be seeing it in the middle of 2024. We're going to start seeing some of this equipment popping up. We're already gearing up. We've already been told that it's getting ready to ship in about 30 to 60 days, which means that it's probably going to hit our shelves within the next 90 to 180 days, which means probably towards the end of Q2, maybe beginning of Q3. So we have to start looking out for this stuff, and we have to start thinking about how we're going to do it and do it properly. And we're going to have to read these installation manuals to do this properly. It's spelled out pretty clearly. I've read some of the install manuals from Train and American Standard, and they spell it out on what you're supposed to do. I've gotten a hold of one from Carrier, and it's pretty spelled out on what you're supposed to do. So whether you want to fight it, argue about it, scream at the sky about the new refrigerants, it's here, guys. It's not changing. It's not going anywhere. We don't get much of a choice in this. We're not going to be able to disband the EPA. I wish California could fall off the face of Earth sometimes, but nothing we can do about it because that's some of the biggest proponents in some of this stuff is California. But that is the good, bad, and ugly of the 454B. Now, with that being said, I think it is going to be a little bit more efficient, but that's just, once again, we're going to have to be careful and see what actually happens with this equipment. So I hope that helps everybody out. And if you've come across any of the R454B stuff or R32 stuff already, shout out, let me know. I'd like to know some more information, but keep on HVACing on. If you like this video or any of the other videos, hit that like button, subscribe, leave a comment, and as usual, happy HVACing.